The next topic we'll cover is determining a chemical formula from experimental data. So we saw in the previous video that we could go from the chemical formula to mass percent, so we can also use mass percent to find an empirical formula. So we're going to start with this example. A compound containing nitrogen and oxygen is decomposed in a lab. It produces 24.5 grams of nitrogen and 70 grams of oxygen. What is the empirical formula of the compound? So when they are approaching these problems, there are three main steps. So step 1, you're going to want to convert your grams to moles. And we're going to do that for all of the atoms involved. So first, we'll start with nitrogen. We have 24.5 grams of nitrogen. And we're going to convert that to moles. The molar mass of nitrogen is 14.01 grams. And that is 1 mole of nitrogen. And we get that from directly from the periodic table. So when you solve that, grams of nitrogen cancels, and that will give us moles of nitrogen. And you should get 1.75 moles of nitrogen. We'll also do the same thing for oxygen, starting with 70.0 grams of oxygen. The molar mass of oxygen is 16.00 grams of oxygen per mole of oxygen. And again, we just get that from the periodic table. Grams of oxygen cancels with grams of oxygen. And that should give us 4.38 moles of oxygen. So we finished our first step. We converted grams to moles. Step 2 is that we want to divide each amount of moles by the smallest number of moles. So the smallest number of moles that we have here is 1.75. So that means we're going to divide both of those values divided by 1.75. So we'll start with 1.75 moles divided by 1.75. And that is equal to 1. And this is going to be for our nitrogen. Remember that the 1.75 was our moles of nitrogen. So I'm just going to put nitrogen there so we can remember what it is. And then we're going to do the same thing with 4.38 moles. And we're going to divide that also by 1.75. And when we get that, we get 2.5. And that one is for our oxygen. So that's how we can remember that we have nitrogen and oxygen. So ordinarily, that would give us our empirical formula, NO2.5. Well, I'm sure you recognize the problem here. We cannot have a fraction of an atom in a formula, which takes us to step 3. If there are decimals, then we have to multiply to get a whole number. So in order to turn 2.5 into a whole number, what can we multiply that by? There are many different options, but we also want to get the smallest simplified ratio. So the best way to do this is we're going to multiply each number by 2. So for nitrogen, we have 1 nitrogen times 2, which will give us 2. For oxygen, we have 2.5 oxygens times 2. That will give us 5. So now that will give us our empirical formula. Which is N2O5. And that is our final answer to this problem. So let's do another for practice using these 3 steps. So find the empirical formula of a substance made of 60.00% carbon, 4.48% hydrogen, and 35.52% oxygen. Well, this one, as you can see, is a little bit different. It gives percentages instead of grams. So if you ever come across a problem like this, where you're expecting the grams, but instead you have percentages, as long as those percentages add up to 100, then you can just assume that, well, you can really pick any total amount of grams you want. Your sample can be any size. So just to make it easy, we're going to assume the sample size is 100 grams. And the reason that we do that is now we know that if we have a 100 gram sample, 60.00% of 100 is 60.00 grams, which means that we have 60.00 grams of carbon. We have 4.48 grams of hydrogen, and we have 35.52 grams of oxygen. So now that we're in grams, now we can do our first step of converting grams to moles. So I'll label these steps to make it easier to follow. So right now we're on step 1, converting from grams to moles. So we're going to start with our carbon. So if we have 60.00 grams of carbon, carbon, according to the periodic table, is 12.01 grams per mole. We can cancel our units, and that is going to give us 4.996 moles of carbon. For hydrogen, we have 4.48 grams of hydrogen. Hydrogen is 1.01 grams per mole. When we cancel our units, that's going to give us moles of hydrogen. And that is going to give us 4.44 moles of hydrogen. And finally, for our oxygen, we have 35.52 grams of oxygen. Oxygen has a molar mass of 16.00 grams per mole. We can cancel our units, ending up with moles of oxygen. And that would give us 2.220 moles of oxygen. Now for step 2, we want to divide by the smallest amount. And that is 2.220. So we're going to divide all of these numbers by 2.220. So, of course, for oxygen, that is going to be 1. For our hydrogen, that is going to give us 2. And for carbon, that will give us 2.25. So as you can see, we have a decimal there, which means that we do need to go on to step 3, which is to multiply to remove the decimal. So what do we want to multiply by? Well, in order to turn the 2.25 into a whole number, the smallest number that we can multiply that by is 4. So we're going to multiply everything here by 4. And we're going to get 9, 8, and 4. Which means that for our empirical formula, we'll end up with C9H8O4. Okay, so why is the empirical formula important when, of course, the empirical formula doesn't necessarily tell us exactly how many atoms are in a molecule, it just tells us the smallest whole number ratios? Well, if you know the molar mass of a molecule, then you can use that along with the empirical formula to find the molecular formula. So that's what we're going to do next. So we're going to use the empirical formula along with the molar mass to find the molecular formula. And here's our example. If a compound has an empirical formula of C2H3O, and the molar mass is equal to 86.09 grams per mole, find the molecular formula. So the first step here, here we go. Our first step in this case is going to be to set up a ratio. And that ratio is going to be the molecular formula molar mass over the empirical formula molar mass. Okay, so we can do that. We even already know the molecular formula molar mass because it tells us in the problem. So we have 86.09 grams per mole over, oh, and the problem does not tell us, but we do have information that will allow us to figure it out because we have the empirical formula. So we can find the mass of that empirical formula. So for carbon, we know the molar mass of carbon is 12.01 grams per mole, and there are 2 of them, which means we'll have 24.02 grams per mole from carbon. Hydrogen is 1.01, and there are 3 of them, which will give us 3.03. Then oxygen is 16.00, and there is 1 oxygen in this empirical formula, which gives us a total of 16, which gives us an empirical formula molar mass of 43.05 grams per mole. So now we can fill that in, 43.05 grams per mole. When we solve that math, we find that the ratio is 2. So what do we do with that number? Now we're going to take that number, so here's our step 2, take the number from that ratio and multiply it by the empirical formula. So we're going to multiply the empirical formula by that ratio. So our empirical formula is C2H3O, and we're going to multiply that by 2 to get C4H6O2. So see how we multiplied each of these atoms by 2. And that is our molecular formula.